Implicit differentiation is used when you have more than one variable that needs to be derived. In most cases, this variable will be y derived with respect to x.
This means that whenever y is derived, its derivative must always appear as dy dx. For instance, the derivative of y cubed with respect to y is 3y squared.
The derivative of y cubed with respect to x is 3y squared dy dx. Keeping this in mind, let's try an example.
What is the derivative of x squared plus y squared equals 5? Well, it's really quite simple.
Remember, we are deriving with respect to x, so don't let those tricky dy dx's sneak up on you. The derivative of x squared is 2x, and the derivative of y squared is 2y dy dx. As always, the derivative of 5 is 0.
Okay, so now that we have taken the derivative, we need to clean this bad boy up. And by clean up, I mean solve for dy dx. So how in the bejesus do I do that?
Well, I like to call it magic, but most people know it as algebra. So, all I need to do is subtract 2x from both sides, and then divide by 2y. Simple, right?
Let's try one more, just to make sure you have the hang of it. Time to get tricky! Y to the fourth plus 3y minus 4x cubed equals 5x plus 1. Now that's what I like to call tricky.
So let's derive this bad boy. The derivative of y to the fourth is 4y cubed dy dx. The derivative of 3y is 3 dy dx. The derivative of 4x cubed is 12x squared. The derivative of 5x is 5, and the derivative of 1 is 0. So, now that we've taken the derivative, let's rearrange this bad boy.
So once again, we will be using the magical powers of algebra. So, let's see how this works. We need to group the dy dx's on one side of the equation, and everything else on the other. So this means 12x squared needs to move over to be next to its best friend 5. Okay, here we go. That's better. Okay, now we need to factor out the dy dx's from this side of the equation. Alright. Okay, last step. We need to bring this guy over to this side. So we will divide. And there you have it.
Alrighty, kiddos, one last implicit problem. This one's a toughie. X equals sine of xy. So let's derive this bad boy. So, the derivative of x is 1. The derivative of the outside is cosine. Then, using the chain rule, we have to take the derivative of the inside, which is 1d2 plus 2d1.
So our next step is to group dy dx on a side all by itself. So, what we need to do is subtract cosine xy and y from the side with dy dx. So what we end up with is dy dx times x equals 1 minus cosine of xy minus y.
Now all you have to do is divide by x. And you're done.
Recording. Yeah.
I can't do this.
Try one more, just to make.
Implicit differentiation is used when you have more than one variable. Needs to be
Derivative of x squared.
In most cases, this variable will be y, differentiable. So, okay.
Derivative of y cubed with respect to x. You have to flip the paper.
Remember, we are deriving with respect to x, so don't let the.
However,
y, I can't say the word.
No. I'm sorry.
Audrey!
The derivative of 5 is 0.
That was calculus.
Okay.
we have taken the derivative.
I don't know how to illustrate this.
Okay. Wait, what am I saying again? Because this is gonna go really fast.
Did you not get any of that?
Snake. I'm a little snake.
Oh my god, I'm not an eloquent speaker. Like, I can't do this.
Eloquence.
So our next step is to group dx dy on a side all by itself. So,
It's dy dx, you loser.
Christine, shush.
this is not fair!
Christine, don't mess it up.
Jeez, Christine.
Come on. Christine, tie it.
I tried it like half.
The whiskers.
Oh my god, it's not funny! It's gonna be hyperventilate! It's my Coke! Can you please get rid of it? I'm serious, no, this is just, oh my god, I can't look at it. So our new function,
Christine, leave.
I'm just gonna leave.